All right, good afternoon, ladies and gentlemen. To a new spring season, a new storm season. I'm Paul Thomason with the Severe Weather Network. And a little background information on me. I started studying weather when I was still in the military. I've been studying and forecasting severe weather for about 16 years now, and I've been looking at storms and doing this for quite a while. I've even helped the tornado tackler on some of his chases as well, just spitting some data at him while he was on the road. He has since taken a hiatus to storm chasing to spend time with his family that he's missed quite a while, so hope that's going good there, Tornado Tackler. Anyways, so we're looking at a new season that has started pretty early, up in February, it looks like, and then now it's starting to really ramp up. So we're getting some good storms here coming up this week. You can see for the day 1, 2, and 3 outlook. Day 2 looking pretty rough, so we're going to look at that as well. But for today, seems like we got storms that are just now kind of kicking up out in the Midwest here, in Arkansas and Memphis and everything. Severe thunderstorms starting to kick up. Some tornado areas with some watches and warnings. Got a mesoscale discussion that's going on here. We can read about that as well. But first, let's take a look at some of the future radar stuff with the models here. And we are within range for the high resolution model, which is my very favorite model. I love that model because it's so decent on the details, I would say. Alright, so the one thing that I do here, there's going to be a lot of educational stuff in here too as well, because I know a lot of people don't really know what they're looking for when they look for this stuff, and I pretty much taught myself to forecast just off of doing it after learning stuff in school, because I started going to school while I was still in the Army, actually while I was deployed. I was deployed to Iraq, and while I was over there I was taking online classes, and then I finished up school when I came back to the United States. And then I did some lab work and things like that out on the road. I did do some chasing out in Texas and Oklahoma with a team out of Oilton, Oklahoma. And that was a lot of fun. It was a good experience. I learned a whole lot. And then I found out later that my school that I went to, because it was inconvenient, I was overseas, 3,000 miles away, my school was unaccredited. So I learned the material, but not really a whole lot of credentials. Anyways. So I've been forecasting weather pretty much since then, and that was 16 years. So that's what we're doing now. All right, composite reflectivity I'm going to pop over to, and then we're going to regionalize this into our target area. So let's see here. We're probably going to have to move it east a little bit, but let's see what we're doing here. I might have to go over to the next eastern portion here, looking at Arkansas and some of these areas here. Now you can see these lines of storms, a lot of isolated discrete cells in here, and these are usually your problem makers. Let's see here. We do have a little bit of hail that's going on here, ship at 1.3, so we do have some hail makers that are going to be making their way across the area. 73 degrees in temperatures, lifting condensation levels pretty low. I got Slinky here showing a nice little hooking structure. Hydrograph looks good for storms. It's a good structure. The updraft is looking strong too. Supercell development is high. We got EHI here, helicity. A little bit of inflow, 1.5, 1.6 early on, and some service helicity there as well. Lapse rates are definitely up over 7.0, which kind of tells me exactly how much instability is in the atmosphere. Wind field's looking nice too. Not a whole lot of jumbling up down here. When you see those winds all kind of mixed up and they're all looking crappy down there, a lot of times that can affect some tornado genesis and, you know, some organization if you have all these wind fields that are just kind of jumbled up and not really organized. But it looks like we got a clean wind field here, so definitely going to be supportive of some supercells being able to produce today. Alright, so some of these isolated storms out front right here, I wish I could actually get it a little bit further to the south. I'm looking at the Ohio Valley here. Let me see if this one... Yeah, that one's better. So you can see these discrete cells stretching all the way down to Louisiana. Some of these isolated cells could be producing tornadoes. It's a little bit low on the scale right now. The instability is way up at 2149. We're looking at 2149 surface cape right there, which is pretty high instability. And then our lapse rates kind of corroborate that with the 7.5 elevation and lapse rates, 500 to 700 millibar. All right, so and then these wingdings right here, I like to call them wingdings. These wind barbs, when the wind barbs are spread out, the more they're spread out, it just kind of tells you how the wind shear is coming together there. And the more spread out they are, the more favorable that they're going to be for possibly some severe storms that could produce tornadoes. All right, so isolated cells, a lot of times they do have those wide out wind barbs like that. You can see these are a little bit wider too. Now this one's showing a little bit more promise on the tornado development, and that's probably going to elevate the longer that we go through and the further that we go through in the scale here. Helicity is up. You can see the helicity levels here at 2.6, 2.7. A lot of really nice inflow that's going on in there. We can actually check that. Let's go ahead and go to our temperature and wind barbs. All right, so you can see our wind barbs are just straight coming in from the Gulf of Mexico, straight up north into the lower southeast portion of the United States, and that's going to bring with it, let's go to our dew points here, dew point and wind barbs, and you can see that plume of really, really moist air, really moist, really hot temperatures that's just coming in here. It's just a really, really muggy mess that's coming into this area, filtering in a lot of moisture, a lot of really, really hot, warm, wet air, and that's going to get into that area and it's going to charge the atmosphere and it's going to make it more unstable for these cells to really build. It's just like throwing gas on a flame for a storm. It's really what it is. So it's going to give that fuel to the fire, and these storms are going to charge up and they're going to be able to really romp around. Alright, so let's pop over to severe weather and take a look at some things here. Let's look at surface-based CAPE and see what our CAPE looks like. So you can see these areas here, reading pretty much what the sounding data was, 2,100 joules of CAPE here and there, and that's a lot of CAPE, a lot of instability. Now, CAPE does kind of one or two things. It either moves with the storms or stays put, and then eventually dissipates. So if we go further in the models, we can see how it's going to kind of work out. It actually kind of maximizes a little bit. The cold front eventually kind of swoops in, and then, you know, some of that CAPE is actually dissipating and kind of moving. You still have a lot of it sitting around, though. In the south, now we're getting into the time of year when the warm temperatures kind of stick around. So that's, you know what I mean, that's going to affect things too, because it's always, I mean, you know, every day in the South, anybody who's lived in the South knows, when you get into the springtime, you start getting into the summer, it's just hot and muggy. It's just, that's the South. That's just the way it is. You know, but that, you know, any day of the week, that's going to help your storm chances. That's really what it comes down to. Alright, so let's take a look at significant tornado parameter and see what we're looking at. So you can see these darker areas here up over 1.0. Anytime that you get these indices up over 1.0 with SIGTOR, you know, you're going to have those higher elevated kind of, you're going to have those higher elevated lines of possibility here, especially here going into Tennessee where you're getting a little bit of that 2.0 upwards elevation in SIGTOR, which doesn't seem to last long, but you still get those darker areas, and they actually seem like they get more widespread as we're going further on in the models. Alright, so that's definitely something that we want to take a look at. Updraft helicity, I always try to look at what's going on the surface or closer to the ground of where we're going to get updraft helicity, because that kind of tells me what the updrafts are doing. Like you can see these darker areas here. Okay, and even though they don't look that significant, updraft helicity, it doesn't really need that much updraft helicity to really get these storms going. So when you look at these areas here, these are probably the more prominent areas where you're going to have the heaviest indications of updraft, and that's going to be supporting the inflow for some of these storms to be able to get rotating, get organized, and you know what I mean? That's where you're going to see some of the increased activity is going through Arkansas right there, where some of that updraft helicity is more favorable. Let me see here. Did I run max? I run max. So it's about the same consistently through most of these 2 to 5 kilometer AGL models from 1 to max time frame. Let's see here. Supercell composite is probably going to relatively mirror the tornado parameter. Usually the tornado parameter is a little bit lower and not as widespread as the supercell composite. And you can see that it is a little bit less, but it follows the same pattern as the supercell composite. So that tells you that any of these areas here is going to be able to produce supercells that possibly could have some embedded tornadoes in there. You know, sometimes these tornadoes that are embedded, they're hidden in there. They'll drop a little bit. They'll travel maybe 3 or 4 miles. Then they'll recede, and then they'll reorganize. Then they'll drop somewhere else. It happens all the time with these storms. They'll drop several times, 6, 7 times before they drop, you know, a significant tornado that might last 20 miles, if at all. Sometimes they never reorganize, and then they just break up, and then, you know, another storm will absorb their energy and then, you know, make another storm somewhere else. This kind of storm convergence, it happens all the time with these storms, especially in the southeast, because there's so much heat and moisture to go around for all these storms to pick from. I mean, you know, it's like if you were going into a store and you were looking for one specific thing, but there was just so many options. It's like a turkey shoot of what you could grab. And that's kind of what the case is with these storms. There's so much heat and moisture for them to grab. They just grab it from everywhere in the southeast. It's not like you know, it's not like New Jersey when you get tornadoes there, because the heat and moisture isn't as prevalent there, so they have to grab it from specific areas instead of everywhere. And that's the case here. There's a lot of advection moving up in here. There's literally everywhere these storms could actually grab that and be able to charge up. All right, so let's go back to our surface and precipitation composite reflectivity here. All right, let's follow the models forward and see what these discrete cells do. Yeah, so these little guys here in the south, usually when I see lines of storms that happen with isolated cells, embedded cells, anything like that, I always look to the south of the line, because usually with that much advection coming through, the south of the line, the southern portion or the southwest portion of that line, is usually the most severe, because you have all that wind shear coming in for the advection, and then it just gets everything spinning up so abundantly there. If it's too close to the ocean with the advection coming off, that's not where you're going to get your strongest storms. Usually it's kind of like midway through the line if it's going all the way down to Louisiana. If it's too close to the ocean, it almost seems like it actually jumps over it and then just kind of runs into the storms behind it. You know, it's kind of weird the way that it happens, but I've noticed it 100,000 times watching storms out here. So you see right now, they're a little early in their development. It's not exactly prime time for them yet. They're in the CAPE zone. You can see the CAPE is sitting here at 2100 joules of CAPE. The lifting condensation level is really, really low, which is when the LCL is real low like that, it's more favorable for these storms to be able to produce tornadoes and severe weather. All right, so and our ship here is at 1.4, so a lot of hail possibly could come out of this. Our supercell development is already up at 5.1, which isn't horribly alarming, not yet anyways. Once that elevates up there, you know what I mean, it's once these STPs kind of come into line and they start to organize, become more favorable for that tornado environment, then you're going to see everything else kind of jump up with it. Let's see here. All right, so see some of these cells that you saw here, like some of these right here, they eventually kind of dissipate, because what these are doing here now is they're kind of going through a power battle where they're kind of fighting each other for energy. So that usually kind of makes them kind of cancel themselves out almost. You know what I mean? Where they try to reorganize and everything, because the way these storms work is that if one storm absorbs another one, then all the building that it did prior to the convergence, it has to restart all over again. It has to reorganize all over again. You know, so that's that recycling process where it builds up, it's ready to go, then it absorbs another storm or the energy from another storm and dissipates that storm. Now it has to charge up and has to do it all over again and rebuild. So it kind of adds time to it. That's kind of what you're seeing with some of these kind of prefrontal isolated cells. They're kind of doing that. All right, so this kind of continues on. It looks like for a little bit it looks pretty consistent until this line. You see a lot of convergence that's going on in here. A lot of different little isolated storms that are converging in with this big blob here you see to the north. This FFD here, it looks like it's just like a big, huge, forward flanking downdraft. Then you start to see some more tornado promise in here as well. Now, the same kind of sounding look that we're looking at with the storms to the south is just now this is, you get kind of what I was talking about, because this is further up into that blob, just kind of southeast of it. And those smaller cells that were down towards the south, towards the southern Louisiana region, they're not really that severe because it's like the advection is just kind of blowing through them. And then now it gets to this line of storms that's way up here to the north. So the advection kind of swoops over these. These are a little bit too close for comfort to really organize, with a decent amount of strength anyways. Then it runs into this line of storms, almost, like an apple hitting a brick wall. And then it, charges up these cells that are embedded in here. You can see all these purples in here. You got some embedded cells probably hidden in there. And it's a little notchy, especially in these areas. You can see a little bit of these kind of bowing areas. If I can actually zoom this in, you know what I mean? You can see these kind of like little bowing areas right here. It's a little notchy. So that's a product of the advection that's moving in, starting to try to get these cells rotating. There is a lot of blowing out in front of them, which tells me that there is probably some winds there, but a lot of rain that's out in front of it as well. When there's sharper lines, not so much blowing out in front of those lines of storms, that's when you get some really, really strong winds ahead of that line showing up to your area. All right, hydrograph looks good with a good hooking structure here. Got a nice critical angle right there. Slinky's kind of corroborating that with the nice little hook structure. The updraft looks good. Not a whole lot of weaknesses in that. All right, and the wind field looks good. Looks real strong. The LCL is real low, 72 in temperatures. Dew points already kind of spiking up towards that 70 Fahrenheit there. So dew points are already getting up there towards the 70s, which is pretty high. There's a lot of moisture going on, a lot of CAPE that's here. 1,500 joules of CAPE. I mean, I've seen tornadoes actually forming like 500 joules of CAPE, so it doesn't take a whole lot of CAPE in order to have a tornado. All right, and I've actually seen derechos actually show up in less. You know what I mean? It just, it's one of those things. CAPE is instability. It's convection available potential energy, and you don't need a whole lot of it to have a significant storm. Especially if you have wind shear. If you have wind shear, heat, and moisture, those three things alone can make a really serious storm. All right, so lapse rates are up at 7. You got 7.0 or 7.1, 7.0 in the lapse rates. It's pretty elevated, so instability is pretty substantial. Helicity up here at 2, almost 3. Surface 3 kilometer. Helicity 2.9. Effective inflow 2.9. That tells me that there is probably going to be some good, nice, decent tornado activity right there in this line. Excuse me. This is where I was looking with that sounding data right here. If we go a little bit to the north, we're probably not going to get the same kind of lookup. Yeah, it's a little lower. So a little bit lower on the scale. A lot of instability here, and it's because that's where a lot of that abundant moisture is. So if you're looking at that as one big, huge structure, which possibly could be forming, so you can see a little bit of a hook. Look at that big notch right there. There's a big, nice notch right here. That's almost kind of looking like a hooking structure right here in the data. So those big notches right there, you could have a bunch of tornadoes that might be embedded in this part of the line right here, this being the FFD, and it looks like a good structure for some tornado genesis to happen there. Right on the border region of Arkansas into Mississippi. And then further down the line, you're going to have some cells that could be training, moving northeast. Training means you're going to have one storm kind of training after the other, kind of like a train moves with the cars, one car behind the other. These storms kind of do that, and they follow the same kind of pattern off to the northeast, and one develops one right after the other. Sometimes you get that kind of thing. Now, I'm not saying this is going to be a tornado outbreak or anything like that, but what I will say is that these storms are probably going to follow the same direction. You could have a couple severe thunderstorms, one behind the other. So you could have some severe storms. Not all of them are going to produce tornadoes. But this definitely looks like right here on this end of the line here of this blob of storms right here. Off to the southwest, this region right here, definitely looking like it's favorable for tornadoes. All right, so as we look at the next frame, now we're looking towards the evening of tonight. This is the problem with the southeast. See, now this has jumped up a little bit in the STPs. You got CIN reading at 2.9. You got the fixed reading at 2.0. And these are kind of consistent. I mean, it looks pretty good for a possibility as far as tornadoes go. You know what I mean? Usually I kind of trust the CIN a little bit more as far as significant tornado parameter than the fix, because they're not always in the same range. You know what I mean? And the CIN sometimes I feel is a little bit more accurate. But when these two actually coincide and they're in the same kind of region of consistency, then I can say that this sounding is probably pretty accurate of what the possibility is. I mean, when it comes from a forecasting standpoint, that's what I've found from a lot of the storms that I've covered already. That consistency right there is pretty adamant as far as storm development. All right, so our lapse rates are screaming up over 7. The same kind of thing. The wind field is real strong. These are really, really strong surface winds down here, all the way up to almost 5.5 kilometers up into the atmosphere. You get big, big wind shear here. I mean, if we look at this, let's take a look at the wind here. Let me see here. Let's look at AGL wind. Yeah, so you're getting some big, huge spikes in some of the wind here. Let me look at the upper air. Let's look at 500 millibar high wind. All right, 500 millibar height wind. Definitely looking, 60 knot wind shear. That's helping out right there. Some of this is really, some of this is kind of it's a little bit more substantial. Let's look at 700 millibar advection. Alright, so if you look at the advection right here that's going on, so you can see the westerlies coming in, and some of those big areas in the upper Mississippi region right there where that advection is kind of, peaking in some of those higher levels. Being able to assist the wind shear in these areas. I see these here is... this is definitely the framework where these storms are going to run into, and that wind shear is definitely going to assist it a lot. Yeah, so we're getting a lot of moisture that's in there, 69, 70s, almost in that area. There's a lot. Then you can see the southerly wind. The southerly wind's moving in here. Then you got the western. Why did I do that? The westerlies that are coming in here. See, this shows the southern wind, and then you saw earlier the westerlies coming in. When you get westerlies going in there, and then you get southern winds that are coming in there, they kind of mesh. You got the dry and the, you know what I mean? This is where the cool is coming from the north and everything. Westerlies are blowing in, the south is blowing in with the heat and moisture, and then they gonna, get jumbled up, and that's where you get your mixing and meshing, and then they start rotating, and that's where the supercell development kind of comes from. And that's exactly the same kind of textbook case that we're seeing here is what it is. Okay. Yeah, this is a very, very notchy line. You can see all those little notches in there, and that's all a product of the advection coming up from the south. Now the line, the big blob off to the freaking far northeast here, is eventually probably going to start winding down, because these cells off to the back, this line that's actually converging and starting to come together here, this is probably going to start to intensify. So where this is going to start removing, you got all these little isolated cells in here. Any of these could be producing early tornadoes off of this as well. You know what I mean? These are all low-end tornado threats for the most part. They do have a humongous possibility for hail and probably some torrential downpours and some flooding risk as well, because you're going to have a lot of rain coming down. It's going to make travel difficult. You're not going to be able to see much. Alright, so this is a little bit of a higher indice right here, because I think I got too close to the line here, blowing a little bit of omega with it. But you can see the supercell development down here at 15.4, significant tornado parameter, and the CIN is 4.3. And the ship is at 1.8. Now, there's either two possibilities. I just got too close to the line of the storm to where I pinged it on the map for the sounding data, or this is going to be a cell that's probably at this time actively on the ground, or possibly could be. All right, so I think I got it right in the notch there, and that big wide notching right there. Yeah, it's kind of hard to, sometimes I get a nice location like that, and then it's yeah, I think it was in this notch. If we pop it just off to the southeast, that's where I got it. Yeah, is right on the very, that's why I always check this area of the line way far to the southeast, or the southwest rather, end of the line. That's where I always usually hit the sounding, because see, I hit it in a different spot and it's still putting out a pretty significant sounding for a tornado threat. I mean, this is still pretty ugly. The CIN right here at 3.8, this is usually why I trust that a little bit more, because, you know, when it comes to the reality of the situation as it unfolds in real life, this is probably more accurate. Even if it doesn't produce a tornado, sometimes these storms, like I said, they go through a recycling process. And what storm chasers hate unanimously is that when they're on the road and they're chasing a storm, they've been chasing it for hours and hours and hours sometimes, waiting for it to develop, because it gets, you know, there's so many cells out there and so much different things going on. It absorbs energy from a different storm. Then they take time to get going. It looks like it's going to rotate and start going, and then eventually it breaks up, and it does, the organization breaks up and never actually ends up forming a tornado. And it's because of that recycling, you know, that recycling that it does, where it, you know, absorbs energy, or something about it, you know, changes in its atmospherics, and then it has to start all over again with its organization, and then never actually ends up producing a tornado. And then the storm chasers are just like, come on, you know. But the good thing is it doesn't hurt anybody at that point. That's the good thing about it. All right, but I'm not saying that's the case here, but it's happened a lot, especially in the southeast. I've seen it happen in the Midwest as well. But the way that this year is going, as far as the storms that we've already seen happening, I don't know if that's the case. I think that these are very promising for being able to produce storms and to produce possible tornadoes out of this situation. So this is going pretty much from the lower end of Arkansas, going across the border of upper Mississippi and across the mid to northern Mississippi range. We're looking at 7 o'clock tonight. That's where this frame is at. And this storm looks like it could possibly already, at this point, have a tornado possibly on the ground. If not, it's going to be a very strong storm that's going to be producing really, really hard torrential rain. A lot of wind is going to be chucked around in there. You're probably going to have some flash flooding as well. This is not a time to be on the roads. I know that people got to work and everything like that. 7 o'clock, hopefully you're already home having dinner with your family, and you're able to get to a safe place in the event of some warnings coming out, because it definitely looks pretty ugly here. All right, so if we're going to trickle down to the more southern regions of the line. I just hit just south of the last sounding that we hit on those isolated cells. Just to the east of those isolated cells, the atmosphere is looking pretty ugly here. Another sounding that looks like it's potential for a good setup, a good tornado setup here. All right, so these isolated cells that are back here, and usually what I find and what I have found, not on every occasion, but a lot of the storms that I've studied and that I've tracked, that western line, that's all the way towards the back of the storm, because back here you're going to have the cold front that's going to be following the storm, and it's going to be pushing along with the east, or to the east with this storm. It's going to be following behind that. If we look at, let's see here, temperature and wind barbs, then you can kind of see the temperatures a little bit cooler up here. All right, where we're getting into the 60s here, and you can see that sharp line. So this is what I'm talking about. That cold front's going to be pushing in behind those storms, and it's going to be pushing them along. But ahead and along that cold front is where you're going to see these storms developing, and that's where they're going to be extreme. So that's, you know, the back of the line right there, where you're getting some good tornado readings. Now, some of these are a little bit lower on the tornado potential scale. You still have a pretty good amount of helicity in here. Inflow at 2.8, Surface 3 kilometer EHI at 2.9. So there's still a really good abundant energy supply there for some storms to really get going. We've already had one storm. I believe it or not, I think it was the one in Michigan where we only had a 2% convection outlook risk for tornadoes, and we ended up getting a really substantial tornado there in Michigan, which was terrifying. This is the same kind of situation that we could be facing just because of all the other accoutrement data that's going on in here. Like you see, these lapse rates are pretty heavy, a lot of CAPE, LCL's low on the ground, EHI's up over 2 and up towards the 3.0 rate, 3 kilometer effective inflow. That's pretty high. You know what I mean? You could see that. That helicity is something that is essential for tornado development. And this is reading on the effective layer STP here that it's a lower end tornado threat. But when I look at all the data, I don't really consider it a low end tornado threat. This is pretty substantial. You're getting a lot of hail in here as well. The ship is at 1.1. I think it's a good possibility you could get a tornado at least for a few miles out of this before possibly it converges with another cell. The hydrograph looks pretty good as well. You're getting a really big, nice, wide hooking structure in that. Slinky's kind of, saying, hey, I'm with the hydro on this one. All right, so the wind field is nice and stable as well. Low-end tornado threats, you can't always look at the effective layer because it's not always going to tell you the exact accurate situation. You know what I mean? You've got a lot of cells in here. These things are going to be fighting for energy and power probably throughout their longevity. They're going to be kind of sucking energy from each other. And every time that one storm absorbs energy from another storm, it just completely absorbs that storm cell. What it's going to do is contribute to the strength of the next cell, of the cell that absorbed it. You know what I mean? So if this northern cell right here is absorbing this southern cell right here, that means that this storm is going to charge up and it's going to get a lot more strength because of the storm that it absorbed. It absorbed all its helicity, all its energy. So now it's going to contribute to its strength and its potential for development. And that's kind of that's why I hate seeing the systems with the isolated cells, because they don't, like this one right here. This one right here is pretty tiny looking when you look at the radar here. It doesn't look like it's going to be anything substantial, right? But these things, I'm telling you, these are big problem makers, these little tiny isolated cells. Because they don't look like much on a radar, but on the ground, this is one isolated area. You could have a whole lot of rotation, and there could be a tornado on the ground right there. You don't know. The little tiny cells, they're definitely something to be concerned about. All right, let's go on to 8 o'clock. This is 8 o'clock tonight. Now you can start to see that convergence take place here. You see these, these lines of storms here kind of dashing off to the southwest right here. They start to converge. You can see these two right here are converging and starting to mix. So if you pop the sounding just to the southwest, or southeast rather, sorry, then you can see that we're getting a little bit of absorption in here. We're getting a little bit of condensed organization, where it looks like the same kind of output, but here you're getting SPP and consistence right here, 1.7, 1.2. It's not that far off, that far apart in a gap. So more of that consistency right there is going to be contributing to its organization. And then look, less cells. You see it now. This is what I'm talking about. Those cells are going to go through a power battle. That's exactly what's happening here. So you got these two big cells that are starting to absorb the energy from the little cells around it. And then it contributes to its development. Now we get a little bit of a boosted potential and tornado risk right here because of all that absorption that's going on. Now you can see our EHI levels are up a little bit higher now, reaching the 3.0 range, surface of 3 kilometer, effective inflow at almost 3.0 in helicity. All right, lapse rates are still up. These don't have to go down. They went down just maybe a point or two, but they don't have to go down that much in order to still be able to, represent how unstable the atmosphere is in that area. I mean, our CAPE levels are still up at 1,600 joules or more of CAPE, which is gonna, it also tells me how unstable the atmosphere is. Lifting condensation level is still low. significant hail. You got 1.0 on the ship right here, so we still got hail. Those wind barbs are really wide out now, and the wind field looks really nice and stable. A nice hooking structure in the hydrograph as well. The updraft looks good. I mean, we've got a couple little areas of instability in the updraft here, but that isn't always accurate as far as the updraft being unstable. It could just be the way that the wind is actually cutting around it into the inflow. It depends on what the updraft and what the inflow and what the winds that are coming from the south are doing. There's a lot of different things going on. This could change momentarily. You know what I mean? So there's no way for the sounding to accurately be able to represent that. All right. All right, so right here, going through Alabama, and you see the storm here, a little bit notchy off to the western side of the western portion of that. But then going up through here, you could have a lot of wind that's going on. We're going to look at 51 to 47 knots of wind shear. But these nice little sharp lines right here in this bowing segment, that means that you could have a lot of really, really hard straight line winds that are coming through. We've got a lot of derechos throughout the country that have kind of had a structure that looks just like this. So I'm not saying this is going to be a derecho, but you could have some stronger winds ahead of those sharp lines. It doesn't look like much on the soundings here as this gets out of the unstable air mass. This most likely is just a whole lot of rain. You still could have some gusty winds going through here. This is looking at 9 o'clock tonight. You can have some gusty winds, maybe blow down a couple of trees, especially with all the rain, how saturated the land gets out there, especially in Alabama. The land gets real soft out there with all the clay and everything and all the red dirt. It gets real soft when you get torrential rainfall. All right, so these bigger storms off to the west, still traveling through Mississippi at this time. Still looking pretty strong for some nighttime tornadoes. Nocturnal tornadoes, folks. Okay, Mississippi gets a lot of them. This is pretty common in the southeast, not just Mississippi, but Mississippi is probably one of the worst states to be in for nocturnal tornadoes. And the problem with Mississippi is that they're not just nocturnal, they're really, really, really heavily rain wrapped. So that's, Mississippi's famous for heavily rain wrapped nocturnal tornadoes, which basically is a bunch of science mumbo jumbo for you aren't gonna freaking see it. You know what I mean? You're not going to see it coming. You're just going to hear it. And if you hear it, you should already be in your shelter. Both of these soundings here are looking like two very strong areas, very strong supercells, being able to produce possibly some good-sized tornadoes, one right after the other. So it looks like these are following kind of the same track. So this is one of those situations where both of these actually produce tornadoes. You could see areas being hit twice. It's a really, really nasty situation, but we've seen it before. This isn't uncommon. Depending on how I'm hitting this sounding everywhere we go here, it looks like a pretty substantial outlook here. Now, if we look at the next frame, it looks like we're starting to get that power down, a little bit more of that reorganization as they're starting to absorb other storms or kind of feeding off themselves. Like I said, sometimes these storms go through a little bit of a power battle. So here off to the southeast, then you're getting a really substantial tornado threat with a lot of helicity in it. This is pretty big. I mean, you could get a good-sized tornado out of that. That's very, very possible. Off to the southeast of the lower storm cell. So it looks like this one has actually gotten a little bit weaker. Still producing some hail. Definitely some torrential rainfall. Probably some good wind as well. Supercell development's still on the rise with this one, so it's still rotating. It's still going to be spinning, but it looks like you got one or two cells embedded in these little individual isolated lines right here, but it looks like one is actually pulling energy from the other. It's probably going to be the further northern one that's going to be pulling helicity and energy from the southern storms and then trying to organize here. That's what it looks like here in this next frame. So you can see this cell getting bigger, these cells down here to the south just starting to completely dissipate. So that's what it looks like, is that this guy right here is starting to absorb the smaller cells off to the south of it. Still, the supercell is really, really out of control right here, but we don't really have the other things that we need to create a nice tornadic storm. There's not, all the other data is not really consistent with it, and that might be because it's in a position right now where it just converged with all these other cells, or all these cells converged with it. Then it's going to power down, have to do all of its organization all over again, and you could be catching that sounding right in that process. That's what it kind of looks like to me. If we look off to the further southeast, outside of its rain band, this is what we get. A little bit of a lower tornado threat, but it's still really substantial. Look at the hooking on that hydrograph. Holy. You know, big hooking structure, 70 degrees in temperatures. 70 degrees in temperatures after 9 o'clock at night. You know, that's one of those things in Mississippi where you're going to walk outside and the only thing that it's going to feel like is, you know, 70 degrees, 68 in dew points. It's going to feel like you're in the rainforest, like you're in a jungle. It's just going to be hot. It's going to be muggy. It's going to be uncomfortable. And then you get that kind of eerie feeling like it's going to go down. You know what I mean? You get that eerie feeling like something's coming, you know? And I used to live in Northwest Georgia, so I've gotten that feeling on multiple occasions because, you know, Northwest Georgia has been hit by tornadoes multiple times. I was actually living there in Northwest Georgia when the big tornado hit Newnan, Georgia. I believe it was 2021. It was the last year that I lived there before moving up north. And Newnan was completely destroyed by a big tornado. It had the same feeling. You walked outside and it was just hot. It was just muggy. It was just really uncomfortable. So that's kind of the feeling that it seems like you might get tonight with this. Now, it looks like this cell actually, as it's getting out of the unstable air mass, looks like it's kind of dissipating quite a bit pretty quickly. So there's like a good window of opportunity for these storms to be able to produce tornadoes, and then as they move out of the unstable area of where that abundant cape was, I can show you that real quick. Let's go to surface-based cape. Oop, I went to CIN, my bad. Surface-based cape here. See, so as it's moving out of this area, then you can see here where these sharp lines are. This is going to be where the cold front is going to be representing right here. You're going to have cooler temperatures up here. It's getting out of that area where it's hot and muggy and everything for the advection, and then it's no longer going to be able to feed these storms, so they're moving out of there and then not being able to really organize into severe storms at that point. So that is our window of opportunity going through the southern regions of Arkansas and into mid to northern Mississippi right there. That's kind of that window of opportunity of tornado development, which is pretty much, if we look at the tornado case right here, it says anywhere in this corridor, but you know, you can see where the little 5% risk right here is, and it's kind of in that significant area of where we're seeing it. You could see those tornadoes continue on into Alabama if they're substantial enough, if they're stable in their organization enough. This isn't going to be able to tell you all the data. You know, this stuff here. You know what I mean? There's many, many times where it looks like the situation, and then when it does roll out, it's an entirely different situation that you wouldn't really normally expect. Just like we had in Michigan, where it looked like, oh, it's just all, you know, kind of a 2% risk for tornadoes, and then we get this big guy who does a lot of damage, hurts a lot of people. We even had some fatalities from that, sadly. You know, so this is why we do what we do. So this is what I'm telling you is the potential for what could happen in this situation. You could have tornadoes anywhere from the lower Arkansas across Mississippi and into western Alabama. Those kinds of regions right here. You could see tornadoes anywhere in that line right here. And the southeast is really popular for heavy, rain-wrapped, dark, nocturnal tornadoes. So if you get a tornado warning or something like that, please, I beg you, heed the warnings and just get to a safe place. Don't go trying to get your phone and trying to film it and look for it, because you're not going to see it. You know, and if you do see it, it's already too late. It's one of those situations, you know, with these nocturnal tornadoes. I know that most people who live in the South, they know how it goes, you know what I mean? But and most people are just like, oh, we're used to this, but you definitely have to pay attention to the warnings. You know what I mean? It's just that's what's going to keep you safe at the end of the day. So, alrighty, so that is the look that is going on for tonight through these storms. Let's take a look at the live weather map here and see what the development is here. Let me plug into a station that's going on here. Now we got a lot of storm tracks that's in here, but it doesn't look like we're really in the. Let me go to a different station here. Let's try this one. It doesn't look like we're in the crosshairs yet, as far as these storms, being able to really ramp up. I think we still have a few hours. The problem with Dixie Alley is most of the tornadoes that go through are nocturnal because they develop later in the day, later at night. The problem too is that during the day in the southeast, it's very, very popular for the southeast to have daytime heating. So you get nice, beautiful, clear skies, gorgeous high pressure weather, during the day where it's nice, it's sunny, it's hot. You got the kids out in the pool and things like that when it's nice and warm or whatever the case may be. But that daytime heating is contributing to the further destabilization of the atmosphere. So when those storms do move into that area, the atmosphere is already really unstable because of all the daytime heating that you've had. And then these storms, they're able to actually ramp up really, really fast and really abundantly. You can see some of these storms are already pretty substantial going across Tennessee right here. And these are just kind of the prefrontal thunderstorms. Not really a whole lot that's going on with those. I mean, if we look at the velocity here, there maybe is like one area, very, very, very broad rotation. Nothing that's really organized yet. And so that is that early development that's going on here. Kind of the early jitters before that storm kind of really moves in. Alright, so let's take a look at this severe thunderstorm down here. Oop, let's move to this station and get a little bit better image. Yeah, it's kind of in between radars a little bit, but that's okay. So, yeah, not a whole lot of rotation that's going on in here. You got some bigger areas of some severe potential in there, but that's most likely going to be where your hail is. A lot of thunder and lightning. You see a lot of lightning strikes in there, here and there, especially in these northern storms going through Vidalia. I think this is Louisiana right here. Oh, this is probably going up into southern, Arkansas and into Mississippi. So some of these storms, I got a lot of lightning that's going on in there. You can see all the lightning strikes and probably a lot of rainfall. So definitely some flooding that's going to be going on in there. Alright, well, I'm going to try to keep a weather eye on what's going on in the development of further in this, and then maybe I'll go live later on. I don't know. I'm not really I'm pretty new with this channel and this whole entire thing and everything. I don't usually do the lives because I've been forecasting for so many years. I usually leave the lives to like Max Velocity or something like that. He's very, very good. And so I usually leave that stuff and the weather coverage overall to them. But because I don't think I'm as good at it, but I know exactly what to look for. I track these storms all the time, and I do it usually with storm chasers, trying to give them a little bit of data here and there. You can see some bright little colors in here with some of the rotation that's going on. So the greens right here, this is going to be telling me that the inflow that's going on in here, that advection, that southerly wind that's going to be collected up into inflow and supercells, it's pretty bright. So we're getting a lot of wind shear that's coming up there. Alright, so then we just gotta kind of, wait for those storms to continue on. We're probably gonna have some more coming from the west. If we look over Texas right here, let's see what we got. Not really a whole lot there. Yeah, so it's too early to really tell. All these stations are not really reading the weather systems here. So we're going to wait and see what happens. We got the tornado watch that is going on here, severe thunderstorm watch for this area, northern Louisiana, southern Arkansas, and into Mississippi. let's look at. Oh, they did remove that area that was down in Louisiana that we were going to check out. Actually, let's look at. Let's look at the meso discussion right here. All right, broadening upstream redevelopment showers, thunderstorms, the potential for increased training. I mentioned that earlier in the video that some of these storms might be training, repeating through the afternoon. So that, again, that is when these storms follow the same path and they train one behind the other. So some of those cells that have previously produced tornadoes or severe thunderstorms, they could be kind of just following the storm right in front of them, just one after the other, almost like the cars of a train following right behind each other. Rates of increase from 1 to 1.5 an hour, with 2 to 3 totals of wet upper soils posing localized possible flash flooding risk this afternoon, which I also mentioned as well. Torrential rainfall is probably going to be very prevalent with a lot of these storms, especially with a lot of the moisture that's going on in that area, a lot of the heat that's in there as well. That's going to be contributing to a lot of your hail. If you do still have daylight hours, this is for everybody. If you do still have daylight hours, you look up in the sky and you see the greenage. The greenage is not significant. It's not synonymous with tornadoes. That is a feature for hail. So that greenage that you see in the sky, it looks really crappy. That usually means that you're going to have some hail that's going to be coming down with those storms. It's not always synonymous with tornadoes. All right. Fairly compact roll-up vortex shortwave over north-central Oklahoma, shifting east-northeast along the interface of strong zonal water lines. Water lines to the north, and increasingly flattening subtropical stream across Texas. This is all the stuff that's going to be contributing to the storms moving into Arkansas, Louisiana, and Mississippi. So this is that early complex development that we're going to see prior to those storms being able to move in. All right, the GOES visible imagery shows increasing clearing downstream east of the Mississippi River with slightly higher surface moisture. That's going to contribute to a lot of your torrential rainfall, your very heavy rainfall. Instability is starting to climb over 1,000 joules, perhaps reaching 1,500 joules, which we saw in the sounding data that was already reaching 2,100 joules in some areas. So that means that there is a crap ton of instability there, a whole lot of instability over the next few hours to further fuel the leading convective cells. Given the strength of moisture convergence, rain rates will be increasing. I think you meant be increasing. Rain rates will increasing from near 1 inch an hour currently. 1 inch, 1.5 inch, 1.75 an hour. So a lot of rain, whole lot of rain. All right, over the next few hours, as the inflow veers, when you get some veering winds in there, that's going to be affecting the updrafts. It's going to be affecting some of those winds that are going to be going into the storms. We just had something pop up here. Let's see what it is. We have a new meso discussion. Portions of northern Alabama and Mississippi into southern Tennessee, severe potential. Watch likely. All right. Watch issuance 80%. So this is a pre-warning to a watch that's going to be coming out into Alabama and Mississippi. The threat for severe wind and hail continues across severe thunderstorm watch 29. Downstream watch issuance will be likely needed by 21 UTC. All right. So this is talking about the cluster of thunderstorms that it's going to be moving through. Continue low-level moist advection amidst filter denaural heating, which means heating that was daytime heating, and then now we're moving into the dark areas of the day where the sun's going to go down. That heating is going to still be lingering there, and it's going to be charging the atmosphere with instability, and that's kind of what they're talking about when they're mentioning that. Has yielded increasing buoyancy. That's that heat and that moisture that's causing that. Coupled with increasing mid-level flow ahead of the subtle mid-level shortwave trough, the potential continues to exist for some intensification with this cluster as it progresses eastward. Yeah, so expected along the southern periphery cluster in close proximity to the surface of warm front. All right, so this is pretty much all stuff that we established with the sounding the sounding models that we were looking at. As we saw, these storms are going to be moving into that area. They're going to be charging up right here on the Mississippi border, getting really, getting a lot of that buoyancy and a lot of that instabilization to be able to organize really nicely, going across the border right there into these later portions of Mississippi and into Alabama, which is why this watch is where it's at. Right now it's just the severe thunderstorm watch, but you're probably going to have some other watches in here, especially when we get down to it, down to brass tacks, when we're looking at cells being able to actually become tornadic. I think it's a good possibility. I'm not saying it's going to happen. Hopefully, knock on wood, it doesn't, but it's definitely going to be an ugly storm that is potential to drop at least one tornado. So definitely keep your devices on, check out your warnings, make sure you know what's going on, in your local area, and make sure that you have some sort of substantial shelter nearby. If you live in a mobile home, please go to a friend's house that has a basement, or a town area or something like that where they have a substantial shelter, because mobile homes are not a safe place to be. Alright, so please get to a shelter. Just make sure that you have, a plan in place for your family to be safe tonight. Alright, so I thank everybody for watching. If anything changes here, I'll try to do another video and throw it up there, or do a live stream or something like that. So stay tuned, and I hope everybody stays safe. Thank you very much for watching.